Okay, so what I have decided that from now on, you can submit your labs. So there are 2 labs before Thanksgiving break, right? So you can submit your lab by 20th, okay? And then I will give the list of the experiment that you can choose from to present on the final lab, okay?
Okay, thank you.
So does that mean all remaining labs are due on the 20th?
Yes, before Thanksgiving break, except the last lab, like the 17th one.
Okay, great. Thank you.
Okay. So, but it doesn't mean that you don't do it the time I'm giving, because you can ask as many questions as you want before Thanksgiving break. And then you can prepare for your final lab. Okay. Okay. So today we will be doing lab number 9, which I was, okay. So you guys got the second battery. Or no?
Where do we find that link?
Did you get my notification to get the second battery?
I don't think
I
so.
don't think we
Would
did.
it be on Canvas?
No.
Oh, maybe I give it to other lab. Okay, it's okay. So what I want you guys to get, so we have this battery, right? I have actually 2 batteries. Maybe you don't have it. Maybe you're one of the battery, melted or whatever. But I want you guys to have 2 batteries at the same time. Okay?
I have a question about that.
Okay.
In my box, I have a clip that connects both batteries at the same time.
No, I don't want that.
Separate?
I know, I have that too.
Okay.
But I want this clip, which has both batteries separate. Okay?
Got it.
So I want you guys, I was actually having 2 batteries, so, and 1 clip, so I got this other clip. Okay, so those who have 2 batteries, they just have to get the clip. But the bottom line is that I want you guys to have 2 batteries with the clips. Okay. Okay, so what we're gonna do is I will go through the lab today, and I will show you the simulation and experiment 2. And everything is on the PowerPoint. I'm gonna share it right now. So it will not be difficult, okay? So just a minute.
Is this lab we're doing, is it in the book also?
No, this lab is not in the book.
Okay.
That's why I did not bring the book today. But this lab is regarding op amps, so which is not in the book. So I was just trying, but it's fun. Okay, so let me give it to you on the canvas. So this is L3. Okay. Okay, you got it?
Yeah, I see it.
Okay. So let's start. I need to share the screen. Okay. So in this lab, we are dealing with op-amps, okay? We actually studied them in the lecture, but this is a good experiment to learn them because they were like, we don't know how to deal with them. So these are an active circuits. We know that what active circuit is. Active circuit is in which you have to provide the power supply from outside as well. And then you can perform multiple operations from op-amps: addition, subtraction, multiplication, division, differentiation, integration, a lot of. And some of your final lab, for some of you, we will build an op-amp circuit. Maybe it will be differentiator, integrator, or so whatever. So op-amps are commercially available in integrated circuit packages in the chip form. And this is the just general description of op-amp. You get output from here, and you have two input signals, VCC, VEE, and you can ground them, okay? VEE is negative and VCC is positive. Now, so this is the first lab in which you are dealing with the data sheet. What is data sheet? Data sheet tells us about any components, nomenclature, configuration, and stuff like that. From where do you get this op-amp? It's actually in the miscellaneous package, like the package which has the paper in it. So it has this, there are multiple chips in it, and I can show you. So this was the bag in which you will have, I think there are two of them. So you can take out one of them, and that is where you have UA741CP, okay? So that's your op-amp. Okay, so on the breadboard, we will put it like this, the op-amp, and you will see that the IC has a notch in it. So notch indicates that the numbering start from there. So let's say if you have the notch here, you can see that the numbering will start like what you should say, the pin numbering will start from the notch. So this is 1, 2, 3, 4, 5, 6, 7, 8. Then if I actually give you the link so that you can take this link and you can open the data sheet by yourself, I can open it here just to show how data sheet looks like. Where is the data sheet here? 1 minute. Okay, let me open it. Just a minute. Just a minute. I am showing you the data sheet. 1 minute. Okay. Okay, so can you see this?
Yes.
Okay, so this is a data sheet. Data sheet, what it is, it actually tells you like the company's description of like at what temperature this device will operate, what are the typical values, what is the size, and stuff like that. So you can see in this document that this data sheet has this normal, like the general schematic, which shows that positive and negative inputs, and these are the VCC, VEE, and then the output. Then if you go down in this data sheet, there are multiple things which Texas Instruments, which make the company who made this op-amp, gave all the information about this. So these are the pin numbers. What we will do with that, we will see that. And then there are the description of the pins, that what is the pin. So I in plus is the non-inverting input, I in minus is the inverting input. Then out is the output, VCC plus is the positive supply, and VCC minus is the negative supply. All these are the pins that we will be using. So we are not concerned with NC offset, N1 offset, N2 right now, okay? Then if you further go down, they will tell what are the minimum supply voltages that you can provide. So they said that you can provide 15 volts to 18 volts, but we are here providing 9 volts because we have 9 volts here. So it's up to you, the VCC voltage, what you provide. What is the difference it will give you when you provide this much voltage? We will see that too, okay? So supply voltage minimum, recommended operating condition, minimum you provide 5 and maximum you provide 15. So we are within this, we are providing it 9 volts. And then operating free air condition, it should not operate more than 70 centigrades. And then, so this is, there is multiple information in the data sheet, which you can get any component, any device that you get for electronics or for electrical engineering. You normally want to get the data sheet first, and you can see what are the operating temperatures, what are the pin numbers, and stuff like that. So similarly, it also shows you some graphs of how much load resistance you apply, how the output will behave and stuff like that. And similarly, what are the typical characteristics of this op-amp. So we will talk about that too. So this is pretty much what is inside the IC. So you can see it's a very, very complicated circuit, but we are just concerned about the out pins of the black box. So this is the PCB layout of the IC. So what are the typical applications? Stuff like that. Okay, sounds good? Now you can open your data sheet and have a look at it too, right? Sounds good?
Yep.
Okay. Okay. So this is about the data sheet. What's happening? Okay. Okay, so now I know that this is my inverting input, this is my non-inverting input, this is my supplies, and this is my output. So that's how I will try to figure this out, okay? And on breadboard, I have to put it in this way, okay? Okay, so this is the saturation region, or whatever you call it. So what op-amp does is, like, when you increase the input, let's say you increase it till 2 volts, let's say, but by the gain of amplifier or the output is exceeding the supply voltage. Let's say its supply voltage was 4 and minus 4, right? So, but it's op amp, and let's say you are providing it 2 volts, and by the multiplication of the gain, its output becomes 6 volts. It will not show you 6 volts. It will show you the maximum output that it can provide using the supply voltage. So supply voltage is its saturation region. Okay, so it is maybe inverting op amp because you are giving it positive supply and it is producing a negative output, but this output cannot exceed the supply voltage. Okay, so the supply, as soon as it reaches its supply voltage, it's called a saturation region. Okay, sounds good?
Sounds good.
Okay. So this is op amp in saturation. So in this experiment, we will talk about 3 configurations. We will talk about inverting amplifier, we will talk about inverting op amp, non-inverting op amp, or voltage follower. These are the configuration we actually studied in the class 2. So let's see. So what is inverting op amp? Inverting op amp is shown in figure. The principal features of this is that it has the feedback loop closed, like you have this feedback loop closed. The closed loop gain is solely determined by the RF and RI. RF is R2 and RI is R1. Then positive input terminal is always grounded in this case, and the closed loop gain of this amplifier is minus R2 by R1. Means that when you have to determine V out, you will multiply your source voltage into R2 by R1. Okay? Sounds good?
Yeah.
Okay.
Yes.
So what we have to do, we have to build the circuit in, sorry, not non-inverter, 1 minute. No. We have to build the circuit in inverting configuration, and inverting configuration as shown in the figure, and then find V out of the as shown in the figure, and then find V out for the following set of resistor and record measured, calculated, and simulated value. So following set of resistor means that your R1 is 10K, R2 is 10K, R1 is 1K, R2 is 10K, R1 is 10K, R2 is 4.7K, R1 is 4.7K, and R2 is 10K. So now you know that R2 and R1, if they are 10K, then what will be the gain here? If they both are 10K, the gain will be 1, right? And if you multiply it with your input voltage, that like here in this scenario, the only input voltage we can provide is 3 volts, okay? So it means that your gain will, your output voltage will be 3 volts in this case, which is not greater than 9 volt, which we are providing as a supply voltage. So we should be, here we should be getting V out as 3 volts, right? Because R2 by R1 is 1. But here, in this case, you can see R2 is 10, R1 is 1. So R2 by R1 will be what?
Negative 10.
Negative 10. And when you multiply it by 3, it will be minus 30, which is greater than 9 or minus 9 volt. So in this, for this set of resistor, your op amp should act in saturation region, right?
So it'll just stay at 9.
What?
The voltage will just stay at 9.
Yes, it should stay at 9, okay? Sounds good?
But so we can't do this lab until we get that other 9 volt holder, right?
Yes, but I have it, so I will do it with in front of you, okay?
Okay, yeah, I just want to make sure.
Okay, yes. So R1 is 10K, R2 is 4.7K, means what is your R2 by R1? 0.47, right? multiply by 3, it should be 1.4 volts, which is less than -9. So this should be fine. This set of resistor is fine. Now, for this set of resistor, again, 10 by 4.7 is what?
.47.
0.47. Multiply by 3.
That I don't know.
Okay, so whatever, it should be, I think, within the range. So that's how we will, you know, you have to fill this for all the resistor set. You have to find out the calculated voltage, simulated voltage, and measured voltage. Okay, so then this is the what you should say, one of the simulation I have done with the inverting configuration. You can see that I have used the feedback loop here, where I was using R2 as 4.7, R1 as 10K, and then 3 volt as an input. And the VCC and VEE were 9 volts. Okay, I will show it to you. So this is one of the simulation that I have performed to see what the output voltage. So output you will get from here. Okay.
Okay.
Okay. Then this is the what you should say, circuit I have made. 1 minute, I will explain it to you. Okay. So in this circuit, this is V in, and this is V E E. Oh, sorry, VEE. And this is VCC. Sounds good? This is the positive supply, this is the negative supply, and this is V in. So what we are doing, my notch is here, I think. So this is second pin, and which is providing a feedback loop here to the 7th pin. So 1, 2, 3, 4, 5, 6, 7. It should be in the, oh, sorry, 6 pin. It should be in the 6 pin. Let's see, let's try to see that. So 6 pin is out, okay? So what I'm doing is I have to provide the feedback loop resistor from 6 pin to 2nd pin. So what this is 6 pin, this is 2nd pin, this is, I think, what is IN plus? Can you check and tell me? Which pin is it, 2nd or 3rd?
Third pin.
Third.
This is 3rd pin, and this is, where is VCC plus? Which pin is this?
7.
7.
7.
No, VCC. 7?
7.
Yeah, it's 7.
Or what is VEE?
4.
Is
4.
4?
Yeah, 4.
Okay, so let's try to see that. So 6 pin should be connected to 2nd pin, and then it's going through resistor to the input voltage. Okay, first we'll just focus on this. So you can see here, 6 pin is connected to 2nd pin. Now it's going from 2nd pin to the input voltage here. Sounds good? Just look at the feedback loop. So this is 6 pin. This is 2nd pin going to the input voltage here, right? Am I clear about that?
Yeah.
Okay. Now what we have to see, we have to see third pin. Third pin should be grounded. So this is the third pin, which is grounded here. Sound good?
Yeah.
Okay. Then third pin is grounded. Then I have to provide 7th pin as positive VCC. 7th pin, this is the 7th pin, and that's I am providing positive VCC. Okay, and then 4th pin as VEE. So 4th pin is this, and I have created another power supply because I have just 2 of them. Like this is VCC and this is VIN. So I have created another, but this power supply is a negative battery. Okay, so in this power supply, I am just doing, this is the what you should say, negative 9 volts. So negative 9 volts you can do by having black line here, black wire here from the battery, and red wire here. Okay, so black and red, and then you make all the like the grounds common. So here I am taking negative here to the negative here, which makes the all the grounds common, because this is my negative 9, this is my positive 9, and this is my 3 volts. Sounds good?
Yeah.
Okay, so this is how you will connect op-amp, okay? We will do that too. Yes, what? So do you understand the pin configuration? Smile.
Yeah, it's a bit confusing, but I think that when we start building it, it'll be a little bit more clear.
Okay. Danny? Danny, are you here?
Yep.
So you're good?
Yep. I understand. Yep.
Okay. So let's move forward. I will go through all and then I will show one of them, okay? Or maybe if we have time. So, okay, so this is non-inverting op-amp. On non-inverting op-amp, the difference is that we have to put input voltage at the I in positive. And the gain is 1 plus RF by RI, which means that V naught by V in is this. So when you have to find V naught, you will just multiply your V in with this 1 plus RF by RI, and you should be good. The closed loop gain again is dependent on R2 and R1. The input resistance of this configuration is very large, okay? So in this case, again, you need to take the same set of resistors and try to find it. So, but in this case, your formula is different because you have 10 over 10 makes it 1 plus R2 by R1. So it will make it 6 volts, right? 1 plus 1 makes it 6 because you will multiply it with 3. So 6 volt is within the range of 9 volts. So you should be able to see that. So that's how you will complete the set of resistors. Again, I have made this in non-inverting configuration. You can see that the difference is that here, where I have to apply 3 volts here, which is my V in. This is my, what was this? Can you tell me? Derek, can you tell me what was this? If this is VCE, which is 9 volts, what was this one?
Is it VEE?
Yes, this was minus 9 volts, VEE. So you can see the difference with the inverting op-amp is that I was supplying at the negative input, but here I have grounded this thing and I am giving input here, which is the third pin, which is IN plus. So I am giving input here. All the other circuit is same. This is the feedback loop, but here the second pin is grounded. Okay, sounds good?
Sounds good.
Another thing I want to talk about is I have two resistors here. Why I was having two resistors, I was checking something else. What I was checking is that if this is my 4.7K, let's say this was my 4.7K, so I was making some other combination of input resistors. I think this was 10 and 4.7K. So if I have 10 and 4.7K in parallel, so this combination will be this, which will make R1 different. So this will be the combination. And this will make my R1 different and my gain will be changed. Okay, so just see the configuration. Don't bother about what type of resistors are they. You do whatever you are asked to do in terms of resistors, that how you connect them, okay?
Okay.
Sounds good.
But you need to change the gain, so you can just change the resistor, your gain will be changed for the op-amp. Okay, sounds good. So we are here, we said that in non-inverting configuration, we will put the input signal at IN plus, which is the non-inverting input. So we are good about this. I have made this again in the LT Spice. And here you can see that I am giving input here and trying to get 10K. So what would be the output I should be reading here? What do you think? Because this is R2 by R1, right?
Is it just going to be 6?
Right, it should be 6 because 10 by 10 is 1 and this should be into 3 volts. That will make it 6. Okay, just a minute. My battery is, okay, it's down. I am connecting in 5 minutes, okay? I'm connecting back in 5 minutes, just a minute.
Okay.